So section 2.4 is called deductive reasoning. This is a method that we use to determine when things may be true or false. So deductive reasoning is the process of reasoning logically from given statements or facts to a conclusion. So we can use deductive reasoning when we have certain pieces of information and we know something about the bigger picture that we can then draw conclusions. This is also sometimes just called logical reasoning. So the first property of deductive reasoning we're going to look at is the law of detachment. What this says is given a true conditional, so an if-then statement that is true, if a specific hypothesis is true, then you can reach a true conclusion. Write that down and we will look at it together and I think it'll make more sense. So get that written down, pause if you need to. Okay, so again, what we're saying here is that if you have a true conditional, if P then Q, that for any true P, we can say then Q. So we've looked at some things before. If a dog is a mammal, let's do this one. If an animal is a dog, then it is a mammal. All right, we know that that's true. But what I can do here is there is this law of detachment that says that these two statements, dogs are mammals, is true no matter what kind of dog I look at. So now I can say, therefore, if an animal is a beagle, then it is a mammal. I don't need a new if-then statement because a beagle is a dog, therefore it fits with the original. Let's try another one. I think I put some on the screen. Let me erase that one so if you need to pause to write it down. Okay, so let's take a look at this. If an angle is less than 90 degrees, then it is acute. That's a true conditional. So therefore, if I say, given measure of angle A is 57 degrees, can you reach a true conclusion? So does this specific information agree with my hypothesis? Yes, it does. 57 degrees is less than 90 degrees. So yes, I can reach a true conclusion, and the conclusion is that the measure of angle A is acute. Okay? So taking a true conditional, a general statement that we know is true, and looking at a specific example of the hypothesis to draw a conclusion. So let's look at another example. If a student gets an A, I should say an A, on a final exam, then the student will pass the course. So I'm going to tell you that this is a true conditional. Maybe the teacher has looked at everybody's GPA and everybody can pass as long as they get an A. Okay, so maybe somebody already has an A, maybe somebody has a D, but an A on the final will get them a passing grade. They're failing now, but an A would allow them to pass. So she knows, the teacher knows that if any student in her class gets an A on the final, then that student will definitely pass. All right, now remember, we cannot necessarily say that the converse is true. There are some students that may pass without an A on the final. So keep that in mind. All right, Michael got an A on the final exam. Can we reach a conclusion? Does getting an A on the final exam apply to Michael as well as everybody else? Of course it does. So the conclusion that I can reach here is that Michael passed the course. What if I tell you Lloyd passed the course? Can I make any conclusion there? No, this is not the hypothesis. This is already a conclusion. I can't draw a conclusion from a conclusion. I don't know what Lloyd got on the exam. Okay? So again, the law of detachment says that a true conditional, if we can write another hypothesis that is true, we can reach the same conclusion. All right, here's a new one. If two angles are adjacent, then they share a common vertex. This is a true conditional. Adjacent angles not only share a common side, but they share a common vertex. So, can I say angle 1, oh, hold on, not share. Angle 1 and angle 2 are adjacent. Can I reach a conclusion about angle 1 and angle 2? Yes. They share a common vertex. Okay. What if I said angle 3 and angle 4 share a common vertex? Can I reach the conclusion that they are adjacent? No. Again, this is already my conclusion. I don't know anything about the hypothesis. As a matter of fact, I could give a counterexample. Here are two angles. If this is angle 3 and this is angle 4, they share a common vertex, but they are not adjacent. Okay, getting the idea? Okay, one other property that we want to look at today is the law of syllogism. This one's a little bit more complex. If P then Q is a true conditional, and Q then R is a true conditional, then P then R is true. Okay, so let's look at one. If it is a holiday, then you don't have to go to school. This is our P, then Q. I'm going to give you another one, and we need two conditionals for this. If you don't have to go to school, oh, that's my Q, then you can sleep late. That's my R. So if P then Q, and if Q then R, then I can say if P then R. So my conclusion can be, if it's a holiday, you can sleep late. So today's a holiday. What's your conclusion? We're not going to say we don't have to go to school. We're going to use our law of syllogism and go straight to today is a holiday, so you can sleep late. Okay? All right, we'll do a couple more of those in class. We'll do some on the homework. Make sure you've taken all the notes, and that should be it for today.